Alrighty then. Welcome to the stream. I'm Agent Ultra, and I'd like to do a little recreational programming with you. It's a bit cold outside, so cozy up with a little warm drink if you got one, or blanket, warm sweater, whatever you like, wherever you're at. And welcome. Yeah, thanks for watching. So, on this stream, I generally do recreational programming on various things, but mostly in functional programming languages, like Haskell. And I might branch out sometimes to other things, but for the past little while, I've been working on a little project to try and build and learn how to build a MUD in a language called Haskell. A MUD, if you don't know, is a multi-user dungeon. It's like a multiplayer server, real-time, but it's text-based. So it's kind of the precursor to massively multiplayer online role-playing games. You got a kind of a shared virtual environment, a shared simulation that everyone connects to and plays in. And so I thought it'd be fun to learn a little bit about Haskell networking, concurrency primitives, and embedding scripting languages in Haskell applications. So where we're at. Just going to set things up and make sure that we're ready to go. Let's get to the code. So the past couple of sessions, I guess, we were working on making sure, we were working on calling the user's Lua code and passing in some parameters to the function that we're trying to call here. And loading that code in. So we're gonna have to figure that out. I don't think I've done the research this week into that. So we're gonna try and figure it out tonight and see what we can do. So the Haskell library we're using embeds a full Lua interpreter, which runs in C, and so uses the FFI interface to talk back and forth between the interpreter and between our program. And the thing I need to figure out is how to load a module of Lua code and call one of the functions in that module. I don't know if there's like a better documentation on this, like a website or something. There's hslua.org, that's right. Pretty sure we found that. Okay, use cases. We want a ready interface. Yeah, we want a ready-made interface to Lua. That's right. We don't need to use any Lua libraries. We do need to expose some Haskell functions to it, but my hope with this is that we can provide like an API into the server to the Haskell, to the Lua side. That sort of thing. So like Pandoc uses HSLua, which is good to know, right? Universal Document Converter. I love Pandoc, by the way. It's probably like one of the bigger open source Haskell applications that's kind of in wide-ish use. So it uses Lua filters and custom writers. Wow, that's pretty wild, actually. What the heck is all this? Oh, there's more libraries here that we could be using. We've just been using the Lua library, the raw bindings to the interpreter. Holy smokes, they got marshalling, which I've been slowly building up. That would be super useful. Okay. Dang. Okay. That's gonna get a lot. Maybe this will get a lot easier. I was gonna have to write all this stuff myself. Check out that package. Peekaboo. Peekers. Peekers an interesting. What is this going on? Peeker collections. Hmm. Okay, we got a push side as well. Oh my gosh. Ha! It's right there. Push the list as a numerically indexed table. I just wrote all the code for that last week. Dang. Dude. Alright, that's cool. Hopefully that, yeah. Let's see, what else can we do? Lua typing, HS2 examples. What? Let's check that one out. Yeah. Module version, Lua utils. Okay, cool. I want to bring that in. What else do we have? Some testing stuff, which is great. HS Lua classes. Oh, I wish it was like more like the storable interface. That would be sweet. Hmm. Cool. So this type class would let us, as long as we provide instances of our types, peek and peekable and pushable, it can just wrap that Haskell function directly. We don't have to like write all that extra stuff. Sick. Okay, there's like a whole ecosystem here for this that I am just learning about now. Weeks into this project. Many weeks into it. Okay, well, that's cool. I'm glad. So, what else can we do? Features Lewis CLI, module system. Where's module system? Okay, the other part, the part of this I really want to figure out is how can I call Lua stuff? That's what I really need. I need to call Lua functions. I need to load a bunch of Lua code, load a whole module of Lua code, and call a function in it. I don't need to provide Haskell stuff to Lua. Well, I do. That's all good too. How do I load the code? Load and run. I don't want to load and run. I just want to load right now. Okay, load the Lua chunk without running it. So it pushes the compiled chunk as a Lua function on top of the stack. I don't want that. I don't want to push it as a function. Why do I have to push it as a function? Just want to load a module of a bunch of Lua code. Is that all we get? Okay, this might be a little bit of a different project now, if this isn't going to work. Test data trace back on ref. Maybe the one way we could do this is we could have like a bootstrap module, like the module. Hey Twitch TD, welcome to the stream. I am getting knee-deep into the Lua interface, like the interface between Lua and the server. I'm really trying to figure out how the heck to load some Lua code and just call Lua functions, not... I just want to load a module of Lua code and call some of the functions in it. But for some reason, it looks like all we can do is load a chunk of Lua code as if it's a function. And I don't know what the heck to do with that. But maybe if that's all we get, we can use some of the Lua stuff here to like kick things off, I guess? I don't know how this would work exactly. Because the code we have right now doesn't work. Really. It compiles and runs, but it doesn't look like it's calling the code. What we have at the moment looks like this. So we're trying to handle the tokenized input string from the server that isn't like a special server command. So it's not a special server command, it's just we tokenize the list in Haskell and try to call a Lua function that will handle that input. Now, token list here is the function that does this. Right? Takes a connection ID, the list of text, the tokenized string. Right? And what it's trying to do is get the interpreter. So take a lockout on the interpreter with a C-string len handle command. We're calling this function on the Lua interpreter. Then we get, at least through our FFI interface, HS Lua get global. Okay. My thought for get global here would be that this would be the handle command in our Lua code. So like a specially named function in your Lua module that we're going to load. Thanks, TwitchD. Let's check it out. Yeah, do string. Okay, yeah. Yeah, this is I've gotten this to work. Right, I can call a Lua module, but the HS Lua interface, so far from what I can tell, loads that chunk of Lua code and just executes it as if it's a function. At least that's what the documentation says. It's kind of weird. Let's see, like... And I've gotten the other side to work. I've been able to push a Haskell function to the Lua stack and allow the Lua code to call it. That's worked. But now I want to pass some data to a Lua function that the user would write in their module and execute that user's function. But for I can't figure out how to do this. This is what I'm trying to do. Function calling. Run Lua operations. Okay. So I'm not sure. Not sure, because we have a load call, right, before this HS Lua get global. So the get global pushes this onto the stack. Right, and then we look at the command result, the result of executing this HS Lua get global, and it is supposed to tell us what was pushed to the stack, and this code is expecting a Lua T function, a thing of a Lua T function type. And if it is, then we are doing a bunch of manual code that there might be a library for that I just discovered to push a table, an indexed table from our list of token results onto the stack as the argument to that function. And then we're trying to, and then it tries to call pcall. Right? And so call a Lua function, pcall. But this doesn't work. At least it doesn't seem to. Yeah, I want to import like a module of Lua code. Right, so if the game developer is working with Bakamud, right? I want them to give me a module that I load at startup, right? And load into the Lua interpreter. Okay, cool. And then from the Haskell side, I want to just call this function. All right, just call this one. Forget all this. Like, I just want to call this function here. So I don't know how to do that. Everything I've seen so far. Yeah, everything I've seen so far, yeah, is like Lua load, right? Loads a Lua chunk without running it. If there are no errors, load pushes the compiled chunk as a Lua function on top of the stack. That's what I don't understand here. If that's going to be a problem or not. Let's just mess with it and see. Maybe that's what we just need to do. So where we load this code is in the network server at the lower level here. Okay, we take the interpreter lock, we open the main libraries, and we call load buffer, but let's try Lua load. Now, the reason why I call it like this, I think, is because this interface actually is kind of like really low level. I'm wondering if one of these other modules might have like helper functions for this. That'll make it a little bit easier. I've just found all these kind of like higher level libraries that are actually a little bit nicer. Well, this looks... Load and run Lua code. Well, it's about the same. Oh, except it's got a little wrapper around it that lets us do load buffer. Wraps Lua L load buffer. Okay. It does the same thing as load. Okay. This might be more what we want. Okay. Let's do this. Let's use some of these libraries and see if this makes it easier. So we don't have to use these lower level libraries. We can just get on with this. Okay, cabal. Yeah, that's what we're gonna do, Twitch TD. We're gonna give this library a try. Okay. We've got Lua. We're gonna get HS Lua Core, I think is the name of the library. Yeah. Version 2321. Let's try and build this. Okay, too high. Let's try 232. That seems to work. Okay, and the other one I want to try is also the marshalling stuff, because I'm writing all of that as well by hand. And it looks like we've got, like, this, I was going to extract this from what we wrote last week, but it looks like they've got a library function for it already, which is great. It's fun learning about all this stuff and having to do it at the low level, but, you know, all good. Sometimes sometimes you just gotta dig in and write it for yourself, you know, before you use a library, whatever, you know, that kind of stuff. Okay, so let's use this library now. HS Lua core. We've got a load buffer. Might give us problems. We'll see if there's anything conflicting. Okay, well, so far so good. Not a guarantee, but okay. Load file. Okay. Oh, cool. Yeah, we can give it the file. We can just give it right the file path, yeah? Yeah? Sweet. Sweet. Okay. I don't know if we'll get a code result. Just... okay, it's lowest case. Okay, we need to run it in a Lua E, not an IO. Okay. So we gotta call that with run. Or run with. Yeah, we're gonna use run with because we have the state. We're taking control of the state, so run with. Which takes the state as the first argument. So I think we could just do... And then the code result stuff is mirror, because we return EA, return A. And we want a status code. I'm not composing these properly. That's the problem here. Let's do it the dumb way. Straightforward way. run with. Okay, that's better. So if you load the file, what do we get? Well, we do get status, which hopefully is just a wrapper. That's its own, okay, it's its own type. What do we use load code result? We check it here, so we expect a type here. So I'll just have to change that. Okay, the file path though, we have that. Right? Mud main module. Okay, so yeah, now we're getting status code, so the status values are okay. Okay, then we can get rid of C string. That one. There. And that one, apparently. Okay. Load file implemented, compiling. Our code, our function calling stuff might still be not going, but let's give it a shot. Call run Bakamud. Actually, let's get our client running. Server client, there we go. And then run the server. Alright, connect. No. Why can't we connect? What happened? Oh, we got an error. Okay, could not load Lua code. Okay. So we got here. We did not get just okay. What did we get? Should be an absolute path of the file, yeah. We're gonna have to do a little more debugging here. On TCP server, mud main module. It might be a text. Oh. That's actually the source code of it. That's why it didn't work. My bad. Load main seems to get the whole file. Okay, well, we could just change that around to load buffer, or yeah, load buffer. Or we could just straight up load string. That might be easy. Might need some conversion. Convert it to a byte string. we have a function for that. S dot, what is it? Encode UTF-8. Byte string doesn't. Oh, from string maybe? Yeah. It's usually encode something. String to byte string pack and car8. Yeah, from string is in UTF-8 string. Okay. Pack. Pack and unpack. No, why? Oh, from car8? Yeah, I need car8. There we go. Okay. Let's go. Okay. Load code result just okay. Welcome to Bakamud. We got our connection. Let's just handle token command. Okay. Okay, we got a whoop. We got a whoop. It's not tokens. We got a whoop though. That's a debug thing, probably. Oh, only there. Okay, so I'm gonna guess we continue trying to interact with the server. It's kind of dead at this point. Yeah, because the thread is probably killed by that error. Oh, okay. Okay, let's use some of the... Let's keep going with this module. See if we can use it to call the function. Okay, call. To call a function, you must use the following protocol. Right. Okay, so you got to set up your stack before this function in a Lua E. Okay. Okay, we're gonna need this, and I'm gonna bring in that Marshall as well, that Marshall module. HS Lua dash marshalling. Okay, we're gonna commit this. Work in progress. Add HS Lua core. No, yeah. Modify Bakamud server here. Added. Just Lua core dependency. Changed. Run TCP server. Calls. It's just Lua core. Load. Main code. Okay, now we'll add marshalling. Uh, 2.3.2. I'll try to match those versions. Probably they go to as a pair, I imagine. No? Okay. 2.3.1. Yeah, they're not versioned in tandem, I guess. What the hell? Microsoft. Okay, everything's running. Okay, so then let's fire up GHCID. Get this bad boy working. Okay, let's just scoop all this out. Okay, we get the interpreter lock. We put a hole. We're not going to investigate that yet. And just get rid of that. What do I have? Show A here. Why is that? We're not going to need any of this in a moment, probably. Just get rid of that. Okay, we're trying to show something somewhere, and it's just getting in my way at the moment, but yeah. Let's calling handle token list. From use of with interpreter lock. Let's get rid of that altogether. Can I just... What GHCID? got a little bit more context. Okay. Just gotta return something. Okay, there we go. 1, yes. Or okay. Okay. So push. Push list. So we still have to run in Lua E, just from the libraries as well, just as we did when we loaded the code. So let's get that else state back. And Lua.run with else state. Okay, that comes from HS Lua core. HS Lua core as Lua. Okay, that's good. Next. We can push list our tokens. So let's bring those back into scope. It is push list. HS Lua marshalling. I import that. Does it have I hope it doesn't have conflicts. Okay, cool. Push list needs a pusher. Okay, so I need something called a pusher to do that. Okay, I don't know how to get a pusher. What is a pusher? Okay, maybe one of these. So our tokens are going to be basically text. We have push text. Okay. Okay, could not deduce Lua.Lua error. E 0. Okay. So push list has this Lua error context that's demanding. What do we do with that? Yeah, totally touch TD. Yeah. Very good observation. Okay, so basically, I guess we could... It's forcing us to handle the error case, basically, which is a good thing. Because if we push list and we say it's text, but something happens with the Lua interpreter state that this isn't possible, it could throw an exception on its side. Yeah, but how can I don't really... Yeah. Don't really care at the moment. I should care. I should care. Okay. So Lua error E1 at M. And can I type apply the E here? It's not in scope. Can I bring it into scope? Scope to type variables. No. I need type applications probably. Yeah, no. Okay, well there's a probably better, we could just use the unwrap that maybe, hopefully, and that should do it. Handle token list. So instead of run with, I can compose it with run either. That's not gonna work. Let's fmap into it. Nope. Nope. Not run either. Just ignore it. Still, gosh, it will not let me ignore that demand for this constraint. Sheesh. Sheesh. Could we... Could I look at... adding it as a constraint to here? I don't necessarily want to. I've got a happy little reader T here that just runs in some MA. There a version of the marshalling stuff, maybe that doesn't have the constraint. Doesn't look like it. Okay. What if... Can I give the type to this way, Haskell? I'm going to enable this temporarily. Lua. What would I even... Exception? Like, I don't know. Okay, there we go. Now it's happening. Okay, push list. Good. Flarp, flarp. call. Okay, so we're going to get global path. And the function is going to be handle command. Okay, then we push our thing on. Then we can call. One argument, 0 results. Okay. Let's see if this works. What's up, System Carl? You learned something about Haskell this week. You know that you have no idea what monads are. Don't worry. It's a never-ending struggle. Twitch TD, why do we need to push a list? Okay, good question. It's because this list of tokens up here in the handle token list on line 101, okay, the parameter, is a list of tokenized, it's a tokenized list of strings, right? So when the user types in to their input, blah, 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 SDF, SDF, DF, right? This SDF, SDF, SDF string or whatever is not a string recognized by the server itself. It's not something I've implemented specifically in the engine to handle. So instead we tokenize that and we hand it off to the user code. The game designer, right, is going to write this stuff in Lua. They're going to get as a parameter to this handle command function a list of strings, right? In Lua, there's just tables. Okay, they don't have like an array type. They don't have a list type. All right, it's just tables, and tables are basically like kind of like dictionaries, and the list-like things or the array-like tables that you can use with other Lua constructs like for and stuff to loop over them and iterate over them are just indexed with numbers, Lua numbers. That's all. So that push function comes in the marshalling library. Which I wrote this manually last week, but there's a library for it now. That's right, TwitchDD. They're integer indexed starting with 1 is the convention in Lua. So yeah. So we push that one as the argument to command, because in main.lua, right, handle command here, this tokens here is going to be the list. All right, so the Lua function, if this call works, should just print that out, right? And hopefully we'll see this on the Lua side, the printed out table. All right. So SDF, SDF, SDF. I don't see the output. No WEF either. We could have just failed and the thread has died. So if we reconnect, we go through the local light, let's like just register a pretend user. Log in as that user. Okay. WEF. Nothing. Nothing. Okay, so we're dead. We died. Okay, so the call didn't work. Let's get that result. Let's debug.trace it. Hopefully before it dies. do I have to thread the standard IOut handler to the interpreter? I haven't had to yet. I think on the C side of things, it is going to get that from the system environment. So as long as I haven't changed that, I don't think I have to provide it a handle. Could be an issue, yeah. But from my experiments so far, that seems to be the case. Like, we've been able to call print from Lua code before, and that's how we like kind of verified that those calls were working before. We connect. Alright, let's just run that. Okay, we get into tokenless start, but nothing else. So we probably crash somewhere in here. Maybe by the call. Maybe we could try the pcall, because it says pcall should be safe. And it pushes the error on top of the stack. I'm just following the example, right? I think so. You gotta push something onto the stack at the beginning when you go to call a function. Alright, there's the protocol here. Right, to call a function, you must use the following protocol. First, the function to be called is pushed onto the stack. Okay. Then, the arguments to the function are pushed in direct order. That is, the first argument is pushed first. Okay, so, function, argument 1, argument 2, so on and so forth. Finally, you call call. N-args is the number of arguments that you pushed onto the stack. So, we pushed 1. All arguments and the function value are popped from the stack when the function is called. The function results are pushed onto the stack when the function returns. The number of results is adjusted to n results unless n results is multi-ret. In this case, all results from the function are pushed. Lua takes care that the returned values fit into the stack space. Function results are pushed onto stack in direct order. First result pushed first, so on and so forth. Yeah. Get global pushes onto the stack. Now this is, of course, assuming that our load worked and that there is now a global named the global we want, handle command, on the stack somewhere, like in the environment of the interpreter. So we could put this here. Handle command results. Maybe it's got shovel on it. Yeah, it might be like an arg should actually be 1, like if it's pushing void or something, some kind of null value. That would be possible. Maybe that doesn't have a show instance on it. Oh, sorry. I need a beep, beep, beep. Okay, type nil. Okay. Type nil. Okay, type nil doesn't sound good. Type nil is probably not a function. Yeah. No, we don't need 2 Haskell. Let's see. Can we try returning 1 to see if it's at least getting called? Let's return R here. We'll call this push list results. And yeah, we'll just see what happens there. Okay, push list result returns nil. It said when we call a HSLua core and run, we have to do our own error checking. So how can we get the, if there was an error, can we get it? Okay, pop exception. So if we use pcall instead, maybe with put pop exception, we can pop off the exception and see what it is. But I'm guessing it's just not finding the function. Try that. Also when we load the module code. Actually, we log that out, don't we? We get just okay there, so it's happily loading the module. It's happily pushing nil onto the stack. But I'm going to put pcall in there instead of call. No margs, no results. Pcall trace. Okay. Okay, call trace. Okay, that could be cool. Let's try that. Nothing. Okay. Good. Register foobar. Good. Good. We try to log in. We're going to log in as foobar. Good, but if we ever try this, no good. Try message of the day again. We're out. We outie. Okay, so call trace didn't do anything for us. So let's just do pcall. Or pcall trace. Let's see if we can print that out. Reconnect. Cha-cha-cha-cha-cha. Okay. Okay, we got our pcall trace result. Error run. Trust results. But I think the nicer thing about that is that, yeah, we can just keep doing that and get the error run part. Yeah, we need to call open libs to get print access to print. Yeah. Yeah, probably true. I think I removed that, didn't I? It's just lowercase l. We're still getting error run, but the pcall at least doesn't throw the exception, so we don't kill the thread. We're getting just error run still. I think it's still because we're getting type nil here. So it's trying to find the global, but there is no global named that in the server, in the interpreter state when we get down to this handle command part. Because, let me, if I go to here, or if I get global, say, print, I think that one will be fine. And this will just print what's on the top of the stack, the first argument. It might not be right, actually, but we'll see if that actually works. Yeah, so it's going to print out some pointer address to the table, but... so, like, we can call Lua library functions, but I don't care about that for this case, right? This use case here. I want to call a user function, right? I want to load that user function into the environment of the Lua interpreter so that it is global and I can call it by name. Right, but I can't do that. I don't think I can. I haven't found a way to do that yet. It looks like we might be in a bind, so to speak. Require, though. I wonder if we can use the require mechanism. If we can only call Lua interpreter functions. I wonder if we can do this with require to load the user code as a Haskell module. And if that is the way we got to do this. Okay, let's try that. Let's go to the Lua manual. Registry might be the way in. Yeah, which we basically call Lua L Open Libs, which we've done. Maybe I can just push the name of the function on the stack too. That might, maybe that could be a thing. Maybe it's not a global. Anyways, modules, this is what I was looking for. Require, loads the given module. Yeah, the function starts by looking in the package.loaded table to determine if the module name is already loaded. If it is, then require returns the value stored at package.load module name. To find a loader, require is guided by the package.searchers and all that sort of stuff. Can we call this to load a package? And then the loader will take care of loading all those symbols into the Lua table, the global symbol table, the interpreter, the environment table. And that sort of stuff. I think we would have to set up the system environment so that it knows where to look in the file system for Lua modules. There might be some default ones, but I think we want to control that. Okay, I'm gonna try, let's just try pushing the name of the function onto the stack as a string. I don't think that'll work, but it compiles at least. Oh, error run, yeah. Well, handle command as well as unit. At least for that. Pushing the string, I guess. So, still an error, so it's not the right thing. Barrow. Push global table. That's not quite it. No. Okay, let's look at require hsload core. Do you have require? Okay. Require HS. There's the other one. What's this one do? Load a module defined by a Haskell action under the given name. Leaves a copy of the module on the stack. We gotta give it a C function, open F, eh? I wonder if I can print out the global environment after we load the code. push global table onto the stack. And get it, like maybe a debug thing. Do-do-do. Okay, then how do we get it off the stack? Two thread to user data to Rollin. Okay, no. No. What is it? I want to know. I just want to print. I just want to pop that value off the stack there. Check is Boolean. Well, I could, like, yeah, I can check if it is a table, but, like... Get table, okay, okay, that... Okay. I don't know. Push global table. Get table. That returns some type. Call it thing. Let's do 1. We will trace him. Return. Status. Okay, and we got the Lua error thing happening again. No, Lua. Okay, we got a Lua exception. Attempt to index a function value. If I do it like that. Yeah. What's a Lua stack index? Thing is type nil. Oh, so whatever is at index 1 is a function. If I try to traverse, let's try and do like maybe 3 or 4 things. V, line it there. Then you data.foldable. Let's try that. Now. Expression syntax in pattern. Good times. There should be a pattern. That's a parser. Oh, sorry, do. We're missing a do there. -ov. There we go. Okay. Yeah, we're running out of time. I just want to try and get a little more debugging in when we can here. Okay, 0. 0 is type no. That's fine. Whatever we get it. So we can't index function values. That throws an exception for some reason. Okay. Let's see. We're gonna have to get rid of this. Pow, 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 pow. And yeah, the foldable. Okay, so a little bit of progress ish. We're loading code. We made it a little bit nicer because these libraries, it's not quite as low level. And we're getting into handle token list, and we're trying to set up a call, but yeah, we're struggling to get still the user's function in this module and be able to access it. I want to be able to get global like that maybe, or like have a way to push that user function onto the stack. But it just doesn't seem to be a way to do that. It pushes nil onto the stack. But it's debuggable at this point. It doesn't crash the thread. So that's something. We'll just have to figure out how to do this. And maybe it might be to see if we can use require somehow, or call require, to use the Haskell interpreter's own import mechanisms to load code. And then that might allow us an entry point into a way for us to call the user's function. It might be through accessing the table, the environment table directly, but it might get loaded as a global, maybe. That would be the best. But I'll have to figure that out next week. So thanks for tuning in. Again, my name's Agent Ultra. All the code you've seen for tonight is in a project called Bakamud. I'm going to put this commit as a work in progress and push it up. And we've added HS Lua marshalling dependency. Changed how handle token list calls the user function, user code. Okay. So that's all up on GitHub under Bakamud. Agent Ultra on GitHub is there as well. Boom. Thanks for watching Twitch TD. Thanks, Carl, and everyone else who's been lurking or hanging out. So Bakamud there. You can also follow me on the Fediverse. I'm on Mastodon on the types.pl server. And you can also find me at agentultra.com. Both have links to this Twitch stream, my YouTube channel where I back up the VODs for this stream. And if you go to the link above my head, declarative.tv, you can follow along there as well. There are other great streamers who are on that site who are doing things in stuff like Haskell or Erlang and other cool languages. Gleam, I think there's some popular ones sometimes. And they're looking for audience members as well. There's also a link to a Discord server where we have a channel for this stream. So if you want to keep the party going and ask questions, go ahead, chat, hang out. And that's all I got for you tonight. So thanks again. May all your types check and all your monads be free. I said it a little backwards this week, but there you go. And happy hacking out there. Take it easy. See you next week. Tuesdays, 10 after 8 in the Eastern Standard Time Zone. Like, subscribe, follow, all that stuff, and you'll get notified when I go online or post a new VOD. So thanks again. I'll see you later.